All right, so before we get started talking about the 10 reasons, if you're not familiar with TiDB, we need to do some background work. Anybody used TiDB before? Anybody that doesn't work for PingCAP used TiDB before? Okay, good. So this is your first exposure to it. That'll be awesome. So first off, we're going to talk about the parts that make it work. And this is going to be a very brief architectural overview of TiDB. So we're going to start from where the user's sitting at a keyboard and then work our way through the environment and talk about the parts and pieces that make TiDB work. So first up, it all begins with a connection. As we can see over here to the left, we have an application and it's connecting via a MySQL protocol. So there's the first thing, and that's going to be one of the benefits is it uses existing MySQL componentry. We're compatible with it, so MySQL clients work with it. So a user connects to TiDB as a MySQL application. And we've got basically two broad categories of people that use TiDB. One is application users, and usually they don't care as long as they can actually connect. They don't care what they're connecting to as long as they can get to their data. So applications that can connect to MySQL can connect to TiDB. There will be some differences in functionality, like if you're connecting with a DBA tool, there's some differences under the covers between the two, but the DBA tool will work and you will be able to explore the system and see some things about it. Next, we can connect with ODBC, that's for your Excel, your Tableau users. JDBC connections work and you'll use MySQL drivers to do the connections. And you can use APIs, which are like the MySQL admin. So the big takeaway here is that your MySQL clients connect. Developers and programmers, you can use ODBC, JDBC, and various MySQL connectors, like the Python connector, the C++ connector, and that. So now we've got a client. We need something to connect to handle our SQL statements, and that's where TiDB Server comes in. TiDB Server runs SQL commands. If there were more people in the room, I would say at least one person in here has got a question about, well, TiDB Server, TiDB. The entire database is called TiDB, and then there's a component in it called TiDB Server, which sometimes leads to confusion. So in your head, you kind of need to keep that straight. If you see TiDB Server, it is what you're going to connect your client to. And the MySQL client is going to connect here. It handles SQL requests. It performs SQL parsing as well. And it will generate distributed SQL execution plans. So this is where the brains of the query are running happen. It's going to optimize your queries and come up with the best way to get to the data. And it also will return query results to the MySQL client. These things are stateless. You can run more than one. You can add to them. You can take away from them. You can do all so they can scale in, scale out, that kind of good stuff. Next up, if we've got a way to compile SQL and parse it and all that kind of good stuff, we have to have some place to store the data. So this area in the middle is the storage tier for TiDB. It's a storage cluster. And the first storage we're going to talk about is TiKV, and it provides storage for the database. It's row-based, so it handles transactional OLTP type data. The data is distributed. It's replicated. By default, there's 3 replicas of every piece of data that goes in there. And it is high availability and can support automatic failover. And strangely enough, it can be used without TiDB. You can write applications that connect straight to TiKV and use the storage. So next, we have another addition to the storage story, and that is TiFlash. So TiKV is online transaction processing, row-based. TiFlash is columnar-based. And TiKV plus TiFlash is what makes us a hybrid transactional analytical processing database, or HTAP database. So when you hear HTAP with TiDB, it means these two components, or these storage area. So it's columnar. TiFlash is columnar, used for OLAP use cases. Once again, the data is distributed just like with TiKV. And not only is it distributed, it can be distributed across physical locations as well, because TiDB is a distributed database. We can distribute across geographies. The next to the last bullet's pretty interesting. It said not open source yet. And there's a line through it because recently in the last week or two, it was made open source. So this is also an open source project. If you've got a database, you've got SQL processing, you've got storage, but the database needs brains. So that's where the placement driver comes in. The placement driver is a cluster of placement driver servers. And what it does is it contains the metadata for the TiDB cluster. It also allocates transaction IDs so that we can keep the data consistent and do MVCC type of things. And it's not written on the slide, but it's also a timestamp oracle there so that it provides the timestamps for the entire cluster for the environment. One PD cluster consists of at least 3 nodes. So 3 nodes is the minimum with a PD cluster. And it hosts a really tiny web server that includes a TiDB dashboard, which is a monitoring and troubleshooting user interface that you can use to fix issues should you have them. Does anybody think of anything we've missed? Anything you'd like to add or you'd like to see in a database like this?
If you store something in TiKV and then want to use it for analytics processing, you have to do operations with TiFlash.
You don't have to do it, but TiDB will do it. What you do is you would issue an alter table command that says alter table foo replica equal and then a number, and what it does, it'll automatically take a table that's sitting in TiKV, replicate it in TiFlash, and populate the data for you. And it'll also keep it in sync while you're using it. We'll get to more on that later. That's a great question. So the one thing that would be missing was in-memory analytics, because if you're going to be a modern platform, you have to have Spark in there somewhere, right? So we have TiSpark. And it runs Apache Spark SQL on TiKV. That's what it does. I believe I mentioned earlier that this is a component-based architecture. You can pick and choose which ones you want to use. You can use Spark or not install it and don't use it. The choice is up to you. I come from an analytics background, and one reason that you may want to do that is if you have a data science team, they're used to using Spark to analyze their data, and this would give them access to TiKV, TiDB data using the tools that they like to use and that they're comfortable with. So something to keep in mind if you're supporting data science teams. All right, and there's a complete picture. I'll give you a second just to take a look at it. Any questions about it? I'm just kind of happy it's staying up and it's there. So no questions? Can you repeat your question?
To migrate an existing application to this model, what are the kind of difficulties?
Can you hold that till the end?
All right, okay.
Perfect. That's a great question. But we don't let him forget to ask. We could spend all day with that, I'm sure. And this is the last presentation. We actually have all day if you're not flying out. All right, so I changed the slide. It said 10 reasons. I put at least 10 reasons because as I was reviewing these today, I hit one and it was like, oh man, I can't believe I didn't put that on. That's my favorite one. So there are at least 11. All right, first it's open source. And since you're here at this conference, I assume you're all fans of open source for the obvious reasons. You can download TiDB for free off the internet, which means you don't have to get anybody's permission to experiment with it or learn it. You can run TiDB in production for free, even though PingCAP offers great support. The gentleman in the back there runs a support group, so you'll want to talk to him. He's fun to talk to, and he's so busy, you normally have to pay to talk to him anyway, right? Yeah, so he runs our support operations. You can learn TiDB for free. There's lots of GitHub, information. There's the documentation. There's nothing better than being able to download it, install it, and get it up and running, play around with it. You can do all that for free. And the last part's pretty cool. You can contribute and be part of the TiDB community. We've got a fairly good community. Not fairly good. We've got a great community. So a lot of people use TiDB. A lot of people love it. Second is the MySQL connectivity, which means that you're not sitting around. TiDB is a reasonably new database. It's not like DB2 that's been around since the late 70s. So it's nice to be able to take something that was written for MySQL and be able to use it with TiDB. So you don't have to sit around and wait for people to develop applications specifically for TiDB, even though we would love for you all to do that, to develop the applications, not sit around and wait. All right, so we support JDBC and ODBC, which are standard connectivities, and existing apps and tools can connect to TiDB. And then we have MySQL compatible, which is a little bit different. TiDB uses the MySQL dialect of SQL, so you don't have to learn anything new. There are some differences, and the differences are TiDB doesn't support everything that MySQL has. So, and then there's some things that we do that they don't, like that replica, that alter table replica statement. And once again, this one's a common theme. You can use MySQL utilities with TiDB, so you can use your favorite tools with it. Next is it's component based. We saw in the architecture diagram that they're bits and they're pieces that you can use or not use. Some of them are required. To have a TiDB server, the minimum things you have to have are a TiDB or a TiDB database. The minimum things you have to have is a TiDB server, a PD, and TiKV. But the Flash stuff you can add, take away. The Spark stuff you can add, take away. And in the future, I'm sure there'll be more componentry that you can add to it and use. So we've got them listed. The PD, once again, that's the brains. TiDB server, that's the SQL parser. You connect to it. TiKV is your relational store, row-based relational store. TiFlash is your columnar-based analytics store, and TiDB dashboard is a built-in way of monitoring what's happening in the system. And if you need new functionality, you can add a component. That's the beauty of it, right? It's open source, so if there's something you want that's not there, you could actually just write one yourself. So it's kind of cool. And if you don't need the functionality, don't install that component. So another reason to use it is the ecosystem. Not only are there our 5 components that make up TiDB server or TiDB database, we also have TiCDC. If you start using TiDB, one thing you'll notice is as you have conversations, it's hard to keep the Ti with whatever straight in your head. You can slur your words, you can say the wrong one, but TiCDC, which is change data capture, you can keep 2 systems in sync with it. The next one is TiBR, which is backup and recovery. It's a backup and recovery tool so that you can make sure that the data that's in TiDB is safe and off-site and all sorts of good things. So if something happens, you can recreate your database. TiDB Lightning, which is a way of importing data quickly into it. It's I've not used TiDB BR much, but I've used TiDB Lightning quite a bit, and it's useful for doing experiments, like getting CSV files and putting them into TiDB so that you can experiment with them. And the next one is my favorite, and it really should. This is the one where I said that I couldn't believe that I didn't make this one of the 10, and that is TiUp, install and manage your TiDB environment. And it's, quite frankly, amazing how quick it is to install TiDB and get it up and running. Lee Schwan here did a presentation yesterday where he installed it on a Mac, had it up and running in less than a minute and a half, right? I mean, it's incredible how fast you can install it. I think in our education classes, it's 3 commands that we use to install it. And then there's a fourth because we hold off and don't install TiFlash at the same time, but if we included that, it takes people 2 or 3 minutes to install it. Any questions? So has anybody used TiDB? No experiment with it at all? Okay. So my goal here is for you guys to go out and play with it after this conference. So let me know if you do that. And then the last one down here is Grafana. And the one previous to it is the TiDB dashboard. So TiDB dashboard and Grafana are very similar. Grafana is a separate standalone monitoring admin system, and it supports TiDB. We use it quite a bit. Colby, what's your favorite Grafana area to go look at?
We have so many.
It's a poverty of riches, right? I mean, there's so many things, it's hard to tell people where to go.
It's really interesting, actually. So back in my time at MySQL and MariaDB, we didn't really have monitoring that was shipped with the products. So if you wanted to do monitoring, you had to find some other tool, you had to build your own dashboards,
Mhm.
all like custom or third-party stuff. So at PingCAP, I was very excited that we shipped like 20 dashboards in every cluster, and some of those dashboards have so much detail. The TiDB detail dashboard, I think, has more than 200 elements in it. So there's a really outrageous amount of detail you should get that's shipped with the product.
Absolutely. The hard part is knowing where to go, right? I mean, that's where Sean's crew comes in. His crew can help you navigate Grafana and the dashboard to learn how to figure out where your problems are in your production environments. Very cool, very cool. And this one is where we'll spend most of our time, and I'm glad we've got Colby, at least Juan here, and Sean, even Sean, and me. Well, maybe not me, but no sharding required, no manual sharding. We have MySQL users. Do you use sharding? You don't? Well, if you ever do, you will remember this and go, I don't want to use this. I want to go back to TiDB. So sharding is basically taking multiple individual databases and trying to treat them as one by putting a layer on top that's smart enough to know that when a key value comes in, it puts it on database A or it puts it on database C or D or whatever. Colby, it was you that was talking about a customer that they tried to add nodes to a MySQL environment and they spent a month and a half doing it, right?
I mean, the basic problem, so say when one individual database instance gets too big, what's your choice? Well, one of the choices people make is sharding, which in some cases this works by using like a hash on some column. So if you say, okay, well, one instance is not enough, let's try 3. So you create a hashing algorithm that sends data to one of these 3 instances based on the outcome of the hash. And you say, oh, 3 is not enough, now we need 5. But your hashing algorithm only goes to 3 buckets. If you change your algorithm to go to 5 buckets, the stuff's in the wrong place. So that's the resharding process.
And you have to manually handle that if you're in a production environment, right?
Yeah, and even if you're using like a sharding middleware to do that, it has to handle it. It just takes time, and you have to move a lot of data around. And so that can be a really big project. It can take months, like Jeff has said. That can take 2 months to make sure that that's planned and executed carefully.
Yeah, we were talking about it last night, and you said that they tried TiDB with it, and it took minutes.
To add capacity to a
Yeah.
sharding system, you have to perform a resharding operation.
Mm-hmm.
Move data manually from existing shards to the new shards. So if you want to add a terabyte of capacity by adding a new server, you have to go through this whole process. In TiDB, if you want to add a terabyte of capacity, you start a new TiDB instance, it joins the cluster, and then PD automatically, completely seamlessly, indivisibly starts moving data to that, and new data starts to go to those instances. So it balances the data across all TiDBs.
Mm-hmm. Any questions about that?
How does it compare to like a company like I think
Colby, are you familiar with Planet Scale?
So PlanetScale is the maker of Vitesse, and Vitesse is a sharding middleware. So there's still actual MySQL server instances running, and then the Vitesse layer handles the processing, figuring out where to send queries. Sometimes it might break a query into multiple separate queries, get stuff from different shards, and then it has to kind of combine it back together into a single result set. So one of the big differences is they're still using MySQL server on the base layer. So any functionality they want has to be in MySQL server. When you plug in MySQL server, they might have to like get MySQL to fix it first or something. Whereas we don't have a dependency on MySQL server. We do what we want when we build it. We do it quickly. And you don't have that weird middleware thing that's kind of between you and your data. So
TiDB server.
So the big difference is that TiDB server is actually the optimizer. It's the compute engine. It's execute the query. So if you think about a system like Vitesse, you send your query to the endpoint that sits in front of your data. Vitesse has to parse the query, figure out where to send it, and then it has to send the query to MySQL. Then MySQL has to parse the query. Then MySQL executes the query, sends results to Vitesse. And then Vitesse has to combine the results from different MySQL servers, do whatever it does, and then send those back to the client. So that's the difference. TiDB is actually doing the parsing, optimization, execution itself, and then sending you the results.
Another question. I actually attended the previous presentation where Ed said that auto increment is killing the system. Is it true, or like
Yeah.
if you have a big table, you have a primary key, like billions of rows, how do you transition to that?
So the big problem with auto increment is that when you insert data into TiDB, it goes into a specific region that's mapped to an individual TiDB node, so it has to be inserted somewhere. And if you have auto increment, it means every insert is going to go to exactly the same region because it's sorted by primary key. So there are a couple ways to avoid that. One is that we actually have a feature called auto random. So you can just change the table definition from auto increment to auto random, and then it'll place the new value across the entire space of 64 millimeters.
Okay.
So that's the easiest way to avoid that problem.
And if you read the data from an existing table that would have been migrated to the system, can there be a hotspot there? Like,
Well,
because you can import, of course the auto increment value can be randomized before.
Right.
At the time it was migrated.
well, if you migrate data into TiDB, the hotspot is the bigger problem on writing. So when you do your migration, you're going to do like a bulk load into TiDB, and then after that, you can change the table statements and use auto random after it's inserted, or after the table is loaded. So you might have the bulk of existing rows will have an auto incrementing ID, and then at some point, the rows that are inserted after that are going to have the auto random feature included in that. Does that make sense?
Okay, and regarding the hotspot, you have at least 3 places where you can read.
Right, so the way this typically, we use Raft for replication, the Raft consensus algorithm for replication inside TiKB. Typically with Raft, you always interact with the leader. So there's a leader and there's 2 followers. All writes go to the leader, all reads go to the leader, and then if there's a problem with the leader, the other nodes elect a new leader, and then all the stuff goes down. So we do have support for stale reads. If you want to be able to spread the reads across the other ones, use case that we focused enormously on yet. It's definitely in the future for us. Yeah, I don't know, one thing I guess that's worth mentioning is the way we handle the splitting of data into the multiple regions. So by default, the goal is to have a region that's about 100 megabytes. When you insert data into the region, as it grows, it'll grow to be like around 144 megabytes. It will be automatically split into two regions. And then PD can handle moving those regions between TiDB nodes to make sure everything's balanced. So if too many regions on one TiDB node are hot, PD will notice that, and it will move some of those to other nodes. Or if there are too many hot leaders on a specific TiDB node, PD can influence RAP to perform leader elections and move the leader role to another TiDB node to balance the leaders across other TiDB nodes. So that's really how we avoid the need to do sharding, because PD is always automatically moving data, making sure that the data is balanced across the TiDB nodes, and the regions are being split automatically. And if you delete a bunch of data, the regions will be combined back together automatically. So that's the meat of how we handle a growing data set, where normally you have to perform this sharding. That's just all handled automatically by PD.
So if we were going to add a 12th item here, automatically balancing hot areas in the database would be one of them, right? So now we're at 12.
Just go through the next few.
Okay. Well, my favorite's install because it's just really easy, but that's good too. Very useful. All right, so where did we stop? So I think Colby covered all these things when we were talking. Easy to scale in, easy to scale out, greatly reduces management headaches, no need to license sharding software, no need to create complicated sharding layers, and TiDB handles the difficult work so that you don't have to. And we've seen that the difficult work not only is sharding, but how its load balances or balances the data across TiKV nodes so that it's efficiently queryable, or it's efficient to query it. Any questions? Tough last session, isn't it? And remember that OLTP plus OLAP equals HTAP. Keep that in mind. That's a big one, a huge one. 2 use cases on a single environment. So what are the advantages of that? So running both use cases on a single environment means ETL isn't required to support your OLAP data activity because it's handled automatically for you. We keep the 2 tables in sync. There's another favorite coming up here that has to do with query plans between these 2 things, so keep that in mind. So how do we know do I have to specifically query TiFlash? Do I have to specifically query TiKV? Those are the questions that we'll answer here in a minute. Running multiple use cases on a single environment reduces hassle and saves money. That's a huge one. Not only no ETL, but you don't have to spin up another database or another analytics engine to support your analytics query. You can do them all on one environment. Robust optimizer. So I mentioned a minute ago, 2 storage engines, TiKV, TiFlash. When I write my queries, do I have to know where the data is? And the answer to that is no. Data is replicated across both of them, and the TiDB optimizer will choose which one it goes to. So you don't have to do anything. You just run your queries. That's an odd one. So any questions about that? That's not typical with databases. Okay, perfect sense. I was hoping for questions. It's like, man, that's just so awesome. I don't have to know where data is. And then number 9. This one is I debated whether to put this in here. This isn't really kind of is a reason to use TiDB, but it's kind of not, but it's important to know. TiDB is not MySQL. TiDB rhymes with MySQL, so they're similar. For example, we did not take the MySQL source code, fork it, and create TiDB, right? TiDB was written from the ground up. It was written to be compatible with MySQL because the folks who created TiDB were MySQL users. They were tired of having to shard data, and they were so tired of it that they decided to do something about it, which is really impressive if you ask me. So they were familiar with MySQL. Their use cases involved MySQL, so they built a database that was compatible with MySQL but is not MySQL. Not based on the source code. There are some differences. When you talk about, when Colby was talking about Raft and replicating data and all that kind of good stuff, those are absolute differences between MySQL and TiDB because MySQL will not do that. One of the advantages of this approach is if your crew knows MySQL, if they have a MySQL background, they have a jump start or head start on using TiDB. A real head start. And I've taught some classes and have seen this firsthand, that when folks such as yourself are sitting in the room and they're MySQL people, they are already halfway through our existing course material before they ever start because the SQL is the same. Some of the ideas are the same. The system tables look the same. There are some additions in the system tables. There's some lies in the systems tables too, which I find kind of funny. For example, Colby, if you can come up with a different one, but this is the one I like the best. You look through it, and when you see engine in the system tables, it'll say I know DB. Well, there's no I know DB in TiDB, so it's there just so that certain applications, when they connect to it, are consistent with MySQL. So it's kind of, I won't say it's a lie, but it's like it's a fib.
Yeah, I don't know what it is.
So that's one of the things that you have to learn. But what's your favorite difference in the system tables?
Well, it's not so much the system tables, but there's a lot of interesting stuff where TiDB will actually accept certain syntax, but just not do anything with it. So foreign keys are an example.
Yeah.
You can create tables with foreign key definitions, but we don't support foreign keys. So it just doesn't do anything with them, which, you know, is not great.
But the reason for that is when people migrate their MySQL stuff into TiDB, it works, and they don't have to go in and edit their
That's right.
SQL.
Those things are all done to reduce the friction of application migrations.
There's number 13. That could have been 13.
What's that?
The ease of migration. We make it simple to migrate between MySQL.
That's a component that you didn't even mention.
I know, that's number 13.
Our DM platform, we have a whole DM platform that stands for data migration. And it's
Oh yeah, I
it's
forgot
its
it.
own cluster of machines that will read from a MySQL bin log and write things into a TiDB cluster. So that's another component that you can choose if you want, or ignore if you don't need it. And remove it when you're done with the migration.
At least 10 reasons to use. Like I said, every time I looked at these slides, I came up with a different 10. It was awesome, to be honest with you. And then the last one that we have slides for is something new, and it is TiDB Cloud. So we have a new cloud offering that's out. So if your use case requires a cloud database, cloud native database, then we've got you covered with that. And it is native. It's a cloud native database. No install, no provisioning of cloud infrastructure. You can scale in, scale out, and in theory, this will help reduce DBA costs because you're not really managing the underpinnings. It's all done magically for you, and it's cloud agnostic. It runs on AWS, Azure, and Google.
Doesn't run on Azure.
It doesn't run on Azure. It's going to. I came from SaaS, and everything we did was on Azure, so I guess by default, just add it to everything.
One thing I want to mention that I think is really cool, so number 7, TiDB's the HTAP database. So usually when we talk about HTAP, we're talking about TiFlash as the column or storage engine that you add if you want to perform analytics workloads. But the reality is that queries in TiDB are already distributed. So that gets you better performance for lots of things than you would get with MySQL. And cluster, you can give it 128 gigs of memory or 768 gigs of memory. You can run this Scalability analytics query, and then as soon as you have your result, you can pull the product. So TiDB servers are completely stateless. They take seconds to join the cluster. They have no impact, and you can kill them or recreate them as often as you want. So I think that's a super cool use case also.
Yeah, that would be 14. Yeah.
That's one of the benefits of the way we separate compute and storage. So there's some other distributed databases that have a more monolithic executable approach, where if you want to add capacity, you have to add a new node. And the new node is compute and storage, but we have those separately scalable. So you can decide how much resources you need in terms of storage, how much you need in terms of compute, how much you need in terms of column pairs. Because you can do all of that independently of other variables.
Yeah, and I have a Teradata background as well, and when you add nodes to a Teradata environment, it starts balancing data, which means adding a node, there's a hit on performance. With what Colby was describing, adding a TiDB server component doesn't require rebalancing data, so it's quick. You can instantaneously add these nodes, and they don't impact. They will impact performance. If you add nodes, they will positively impact performance. So, you know, it's kind of the best of both worlds. I put the cloud back up there because she's taking photographs. We got it to work, by the way. They got it to work. All right, so we think the cloud is a huge deal. You know, a lot of people having use cases move to the clouds. Are you guys using cloud? Which cloud are you using? AWS. Anybody not using AWS? Okay. Nobody's using Azure, right? Cool. All right, so we've got time for questions. You had a really good one. I'm going to bring back up our architecture diagram. So ask the question that you asked before.
So imagine that you have a existing MySQL application. Well, MySQL database, there's a lot of data. Or is it the use case that you can migrate to this, or you would just start doing stuff there and hope for the best, so that your developers see the difference as they develop, because it could be there could be so many differences
Flash works, when you insert data, the source of truth for the data is in the TiDB cluster. And then you can optionally enable a TiFlash replica on a per table basis. So if your goal is something like a data warehouse, it wouldn't make sense to pay for 3 replicas of transactionally consistent data in TiDB just to get access to the TiFlash column store.
That is a replacement for OLTP, and that gives you time flash.
That's right, yeah.
If you want to do some analysis.
That's right, yeah. And one of the things that becomes very cool when you have the ability to do that type of analytic workload on your real-time data is that you have these real-time insights into exactly what's happening with stuff. You're not having to do an ETL process. You don't have to run some job that's always operating on outdated data. So the idea of like being able to build more dashboard stuff, being able to show customers what's happening like with their account or with whatever. Another big use case for something like TiFlash is fraud detection. So if you're able to do aggregate queries and detect patterns, you can do that in a real-time fashion rather than having to work on stale data.
So, and all that works with the real data warehouse like PingCAP.
So TiFlash